Alright, time for another DraftPhysics.com, DebatePhysics.com, also video presentation on the subject of gravity down there. Yeah, okay, so I'm going to read what I wrote anyway on the subject of gravity, and you know, it's just so simple, and they've made it such a mess out of it, but they've made a mess out of everything, and it really, I mean, I've been watching some Sean Carroll videos and these other people, and they talk such rubbish. I mean, it's just such mush, you know, about the universe not made of anything real and nothing's in a real place, and it's just too fucking ridiculous. So anyway, just very depressing. So anyway, I'll try not to, you know, be overcome by my disappointment in humanity, and so just make the argument anyway. Alright, so I titled it, "It Eats Entropy and Makes Matter Hot and Fat with Complexity." Gravity does that. So the second law is nonsense. There's no degrade in the condition of the universe. It's constantly rebuilding through this simple process of gravitational attraction. And that's only one part of the story, but anyway. Alright, I would first state that gravity is more an effect than a cause. So everybody should be agreeing with that, that the effect is what we see. We see things get momentum and they fly into some kind of bigger mass. And that's the effect we see. Alright, it's an action. It's, no, it's not, gravity isn't a substance. It's a consequence. Anyway, gravity is not itself a substance. I just said that. It's an event. What is known with certainty is that gravity behaves exactly like light emitted from a spherical body, a sun. So it obeys the same inverse square law. There's nothing magical about that. So the light is a divergence, light spreading, more entropy, you could argue. And gravity is the exact opposite. It's a convergence. Okay, spread out stuff is converging on the center of the gravitational body. The only difference being a difference in direction. So no big deal. Same, it can be just understood. You know, light's a force, light's stuff, and that gravity is likewise stuff. It's just that it, you know, our eyes can't see it. Alright, light diverges obeying the inverse square law. Gravity converges obeying the same law. So I just said that. Alright, so here's the part that's important. Light heats or pushes on things proportional to the exposed surface area. So it's just about the light hitting a surface. It doesn't really penetrate, and you know, it functions. It affects and interacts with things' surfaces more than their total substance. Okay. Gravity similarly transfers momentum proportional to a material's weight or mass. Yeah, that's how I should say it. Proportional to a material's weight / mass. So instead of caring about the surface area, gravity cares about the density, the amount of substance. So the sail, if you were to think of it as a sail catching wind, is it's not about surface area, it's about the total mass of the sail. Alright, the parallels are too obvious and real to be reasonably ignored. I mean, it's just so clear that gravity is not doing anything but the opposite of the explosion. The exploding divergence that you can see all over the place, it's doing the opposite. It's creating a convergence. The pushing effect, can't see it. of gravity, like the effect of sun tanning, is being caused by a force. So it's just as real as the photons that burn your skin. Gravity is just as real a thing, and instead of burning your skin, it's banging into your electrons and protons and giving them momentum. Alright, real bits of energy burn skin, and real bits of energy push matter towards the center of an Earth. Okay. Can you see this? Yeah, you can. Okay. The short story of gravity is understanding it as a simple force differential, i.e. more force pushing you in than force pushing you out. Now, that seems simple enough an argument that it's just a balance of force, and it's by this inverse square law, and the Earth is really just a sink of some kind. It's stopping energy from getting to the surface, and so you have more energy hitting you from open space than you have from the Earth. What creates the differential is the fact that energy has its speed reduced when pushing matter, and that energy delayed is in essence energy delayed is in some sense energy lost. So you can sort of understand that if something's coming for you and somebody slows it down, like there's a bull or something, by giving you time, you can move out of the way because it plowed into somebody else first and was distracted. And so you can have a different outcome based on the fact that something else did something to the energy to prevent it getting to you at the time it would have gotten to you. And so in this sense, it's important what time it gets to you, because there's a force pushing you all the time, and if the other force is slowed down, then you're always behind. Okay, there's always less total force coming from underneath than it came from the above, and you're stuck in that differential. In other words, when matter moves, it retards the force moving it, and that force will be late getting where it would have been. So to push electrons and protons, the force is being slowed down, essentially, because the matter's big and it's harder to push. And so therefore, the force that would have balanced, you're out here somewhere in space, the force that would have created a balance so you don't have a differential, well, that force didn't get to you. It got slowed down. It's going to get to you too late, and so you're stuck in an imbalance. Alright, when matter moves, it retards. Okay, we said that. The would have been, in this case, equalizing the force pushing something into the Earth. So you have the external force pushing down, and you have a delayed force pushing you back up. And that's the ingredients that create the force differential that you fall in. Alright, I put it more than one way because this is a really important point. Put still another way, matter pushing towards the center of the Earth is distracting energy from its would have been role of equalizing the force pressure an object would have experienced if the Earth did not exist. So obviously if the Earth doesn't exist, I'm sitting in the space and there's an equal amount of force hitting me this way and an equal amount this way, and I just stay here. But with the Earth in the way, it pushes matter this way. It's also pushing matter this way, but that way doesn't matter. It's irrelevant to me. The ones that are important are the ones that would have hit me, not the ones that never would have hit me. And so it's absorbing energy, essentially, for a period of time. It's storing it. And that process means I didn't get my hit that would have stopped me from moving. And so I'm going to move because I'm not getting hit enough this way, and I'm still getting hit the regular amount this way. Alright. Primarily unrecognized by physics is the correlation between gravitation and heat. So, I mean, everybody knows, okay, that all these things are hot. Even the moons of Jupiter, it's pretty well understood that they're all liquid on the inside. You know, that even if they have a frozen crust, the inside is plenty hot. Okay, and even the moon. Okay, large objects in space have hot cores, so the bigger an object gets, the hotter it gets is kind of the obvious point here, because it's more and more pressure. All of the mass is the thing pushing on the core. The more pressure, the more heat. So the bigger it is, the hotter it gets, and the sun is like a pretty damn good example of what happens when you have enough mass in one place. It gets really frickin' hot. Alright, this heat is the byproduct of the constant cumulative pressure being exerted from all directions by mass pushing towards the core. So from all sides, the core is feeling all of this weight, all of us sitting on it, okay, and we're squishing the hell out of it. Alright, if you were to build an Earth in space by incrementally adding mass to a meteor-sized object, so this is kind of a nice example, because the meteor would be, let's say the meteor was a mile around. Okay, it would be warm, but it wouldn't be really hot. But it would be warm, because it's real pressure. Every rock, you know, making up the meteor is moving towards the center, and it's all placing some pressure on that center and heating it. But it's not going to be very hot, okay? And it's not until you make it heavier and heavier and heavier, it gets hotter and hotter and hotter. And the temperature is basically telling you how much gravity there is. The more mass, the more gravitational pressure, the more heat. So the Earth being, say it's 1/3 of its substance is all molten. You know, that's the amount of energy the Earth is producing as a gravitational effect. So if you could calculate the energy of all that heat in the core, that's how much energy the gravity is capable of producing, let's say. Its gravity would increase proportional to the increase in internal temperature. So as you make the thing bigger, it's going to get hotter. Hotter and hotter and hotter. Okay. An obvious deduction is to see the heat as a measure of how much energy the object retards from balancing the force in the space surrounding the object. So the heat is just telling you that's energy storage. And this is how much energy didn't escape the Earth, and this is why there's gravity, because a ton of energy is stuck heating the core of the Earth. Put simply, the heat represents the amount of energy that isn't radiating out of the object, which in turn causes the energy differential between the force pushing in and the force pushing out. Alright, so not too much. Obviously I have to go into more analogies and details perhaps, but it certainly is the outline of a pretty clear understanding that all you really do is account for the fact that, yeah, the Earth is hot. And why is it hot? Because a ton of pressure is being applied. And what's the consequence? Well, there's a bunch of energy in the core of the Earth that isn't flying free in space. That's the, you know, if you believe in energy conservation, you sort of have to understand that, well, if the Earth is all molten and hot, then the only place that energy would have been is someplace else in space, pushing something, you know, or potentially pushing something. So it's clearly the outside must be colder because the inside is hotter. Obviously. Okay, so the other part will be the atom, and I haven't quite that's going to be tough, just because this is when you get into the whole thing where you really need visual aids, because, you know, describing the surface of a atomic nucleus you know, isn't going to be it's something you need to draw, but anyway, it's I've started it anyway. And so anyway, so it's moving along. So, you know, we've got the beginning of just the idea of force. It's a push universe. And then we get into the simple mechanism of charge that really is the only mechanism. And in the end, it leads to Okay, the ability for the Earth to store energy as heat, which in turn creates the gravity, and then you can start talking about how this process creates these atoms, which are again anti-entropic, and are storing another form, the same energy, but storing it in a mechanism that's not obviously hot. But anyway, alright, so maybe that's enough. Keep it short and to the point and all that crap. So again, not much in the comments. Some guy left a, these people, they write comments where they say something like, the simulation doesn't work, or something like that. And it's not, you can't make that argument. Of course, it does work. And of course, if you're going to make an argument, then you have to see, this is the way to do it, right? If you want to make a counter argument, you take some sentence in this paper, link below. You take some sentence in this paper and you say, aha, I can prove that not to be correct. But you don't take whole concepts and just make some vague statement. That's a waste of my time. And he was clearly nowhere even close to accurately describing what I just read. I mean, I directed him right to it, and he didn't in any way recognize this simple argument that you can just look at how hot the core of something is and deduce how massive it is. Heat is a representation of gravitational pressure. And physics has ignored that simple truth. Overlooked it entirely. Alright. So I think that's enough, really. Yeah, I don't really think there is any new comments or worthy comments, or, it's really no point. Gotta do it. That's not much of a comment, thanks. And yeah, the rest is all old stuff. Okay, so till the next time, and such and so forth and whatnot. Yeah, that's enough.